So my name is Lukas. I'm from ITERATE. We are an API company. And today I'd like to kind of propose a better way to do APIs. Because I've seen a lot of APIs, and I usually don't like what I see. So chances are some of you will create an API, and I may use it. And if I will use PayPal API ever again, I'm going to be disappointed. And as someone said, the disadvantage of using a real name on GitHub is I can hunt you down, so beware. But first, lessons from the past. What is the first API you can think of? I thought about it myself, and I have actually one particular in mind. And that is Czech National Bank's currency exchange. And it's a simple dump. It's a CSV file. And when you think about it, it's actually quite good. It's simple, it has a simple structure, it's lightweight. It's actually a hipster API because it's RESTful before it was cool, before it was invented even. But in a sense, what API is, you want to modify the state, you want to modify the data, which unfortunately you cannot do that with a CSV dump. So back then, our ancient ancestors invented XML RPC. It was sensible back then to use XML. So we have this kind of hairy protocol for manipulating the remote states, but there was not enough XML in their XML, so we put an XML and created SOAP, which was a more horrible abomination, but it actually worked. It worked, but there were some problems. And I mean, the main one is obviously SOAP was overly complicated. But also, it's a serialization protocol. It's a procedure call. And what they have in common is you have one endpoint, and you basically ignore all the HTTP things, which is one problem. Because, you know, everything gets better. You have more bandwidth, you have faster processors, you have more memory, but one thing is pretty constant for the last decade or two, and that is network latency. It's not getting much better. So you have the one main point in the whole process, and XML RPC and SOAP try to abstract it away, to pretend it's not here, that you are calling like local procedures. And that's a problem. It's really not a good way, it's a leaky abstraction. So we moved on, and REST appeared. There was another flaw in SOAP, and that is because it is a protocol and it is a procedure call, you are enforcing your own conventions like the camel case and other sort of thing. So if you have a Java SOAP API and you are using it from Python, it does not fit. It's really not getting together. So we moved for REST. And what's different about REST is it's not a specification. It's only like a philosophy, a way to design things. And that's kind of problem on its own because the philosophy is very simple, but to design the whole API is really hard. Anyone here designed REST API? Actually, not so much. Yeah, so to design it is not a simple problem, partly because of that. And we have like the ancient tome given to us as a prophecy, and we have disciples arguing over interpretation. So they are not different enough to call it with some other three-letter acronym, but they are different enough to create a bloodshed. So you can argue about verbs and about headers you should use and so on and so on. But it's still the best we have. So if you are designing API, please do it the REST way. It's now, I think, 80% of the public APIs, or as registered on Programmable Lab, are REST. So fortunately, both XML RPC and SOAP is dying. And we are moving on because REST is not solving it all. there are the hypermedia APIs. You have the real-time APIs for server push, and they are not this is not a solved problem, so I'm not going to talk about it yet. It's like really the frontier, and there are not the patterns we can learn from. But there are some on the REST APIs, and we have observed how APIs developed and how they are evolving inside companies. And we'd like to present some better ideas because there are three main problems we've observed. First one, and by far the biggest, is kind of the Ivory Tower approach to design. This one is really interesting because we've learned from the waterfall problem, like we are talking agile all around for a decade at least. But when we are designing APIs, what we observed is still that it's like there are clients, like we want to create mobile application, like for iOS. So server developers and our team, please give us an API. So then the whole team gets into the Ivory meeting room and creates flowcharts and creates like spreadsheets, and then they present nice and normalized list of resources, and they present their application logic, and it's all nice, it's normalized, you can call everything, but then you have to create aggregates, like you have to show dashboard, and then you discover you have to make like hundreds of API calls, and you're screwed. And this is exactly the waterfall problem, but like it's still there. We are not communicating with the other side enough. And when the server people are designing it, they often have the fallacy of kind of exposing their ORM objects. There are even frameworks for that. At least in Django, there's like Django Piston, is it? I think. But it is like you put your ORM object and say you can do select on those fields and update and expose it as an HTTP verb through a JSON in this URL space. And it sounds good because it's simple, it's a few lines of codes, and hey, you have API. But I come to really dislike this approach because you are not thinking in terms of use cases. You are thinking in terms of your database. And you are not abstracting your data store away. So you are not really future-proof. And once you have to kind of denormalize things in that database and migrate and move on, you are creating incompatibilities in your API. You necessarily don't want that. So please don't do this one. So really create a nice API, think in terms of use cases. Second thing, like all-time programmer favorites, documentation. From those of you who have REST APIs, do you have at least a list of resources your API contains? 1, 2, 3, 4, okay, not much. Yeah, so creating documentation. Actually, we learned a bit from this one in Python community because if you have the documentation tests, they have a bad name because they were used very improperly in Django for testing. But if you use them like for their original purpose, which is you embed code into your documentation and you can test it with every release, it's really a way to move forward. And the next thing, which is with the documentation, because without the Autodesk documentation, it deteriorates. Like you update your code, you forgot about the documentation, and it's really interesting how often this happens, even on the big portals. And the second part of this problem is the evolution of not only resources, but the payload. You send some data, and then you extend the schema, you add some fields, and then you rename them, and everybody is screwed. And actually, this is one of the few things XML got right. it's really a good idea to use some sort of namespaces, as in schema namespaces. So you can have one API. You share the resources, but you can differ only in the payloads based on the namespace attached. And the third problem we saw are bug reports. When you use your API, something don't work, and you want to send bug reports to the upstream, and there is a company and there's a first-line user support. So it's like, yeah, we have a problem with our payment system. Oh yeah, our payment system, yes. You are not properly terminating your keep alive connection. Yeah, keep alive connection. Have you tried to turn your computer off and on again? No, please give me the technician. No, please restart it first. So each and every time, please give support for developers by developers. Well, these are the three main areas we saw as problems, and how to solve them. It's actually quite easy. Use software solutions. We are actually quite good at solving those problems in software. We are just not applying it to APIs. So do not design in Ivory Tower. Use prototypes. Quick hacks. Offer a prototype of an API to a consumer. Develop your mobile client on top of that. See if it works, and then refactor. Fill some real data. It really saves a lot of time. We all know that for, I won't say the Scrum word, but it's really about the iteration and feedback between both teams. Of course, you have to balance when you open up your API and say, this is not prototype anymore, this is stable, because from then on, you have to think about the backward compatibility and versioning and payloads, as I have said before. Also, please do regression testing. Please really do. Once you open your API to the public and you are, let's say, Twitter, you can really screw a lot of people when you kind of only miss one header. Please decouple. Do not expose your ORM directly to the HTTP client. It's not working real well. Do prototypes, but also plan for future. And as said, the unique on kind of API ecosystem is that both sides are developers. So please talk to developers in their language. Do not send them to first user support. Do not send them the kind of manager PH dev tome saying how cool your system is. Just show them the resources, the examples, and the SDKs. And because I have some time, I'll show you it's really the thing we want to change as a company. So we are building a product around this. And if internet works, I will show you some demo. What we are solving with the kind of development and prototyping thing is we propose a DSL language. It's really, it cannot be any simpler. It's on top of Markdown, it's extended Markdown. And you can write your code very simply as an email. And this serves as both documentation and a server you can develop on. So if I have a monitor here, okay. I'll try to show you. Is there a mirror? There's a reason you should never do a live demo, because I want a mirror, my mirror back. And I'm not going to bother. Let's continue with the presentation. So, yes. Our approach is to specify what you expect, and from that you can iterate. And the main selling point for us is this can be in your repository. You can talk with that language. It provides you a communication channel. And just from that, you have documentation, at least as a list of resources. But when you annotate it with the markup, you have really solid-looking documentation you can show to the other side. And once you have the server implementation, like you came to conclusion and you can look at it, you have a thing we call inspector, which is basically you send your requests through the proxy, and you can see the smart diffs on how both the server and client are differing from basically the specification, the DSL, the language you agreed upon. And what's kind of cool on that is it can live in your repository, like one of the things we are used to. You can branch it, you can send pull requests. So you can really build your community around. And this is a thing we can really think you should do this with your API, even if it's public, even if you are Twitter. Your implementation is proprietary. You can still open up the blueprint, the specification, and the others can play with that. So you are developing a client against Twitter. And what you can do is like, well, we are missing this feature. It might make our client better, so let's fork it, play with it, create a mock server, test our client, and then you can send back, like, if you implement just this one simple resource, you will save hundreds of API calls from us because we will aggregate it under one. And as a provider, you can consider it, and this is the way you can publicly iterate and make your API better for the greater good for all of us. So thank you, and I'd like to take questions, if there are any. Yes? Sorry?
When is your product going to be?
It's released already. It's apiary.io, you can see that. The parser is on GitHub, so you can, it's open source, you can play with it. Anyone else? Okay, so then thank you.